Everyone, this is Vincent Tan speaking. This time, I'm going to talk about TNV6 heat recovery, the operating modes. For your better understanding, I provide the corresponding video linkages at the below description area just for your reference. Meanwhile, I also provide the correct subtitle. Don't forget to turn it on if you need. First of all, I'd like to introduce how the refrigerant flow inside the TNV6 heat recovery system. On this diagram, you can find that there are two outdoor units and connect with three mood exchangers. And on the outdoor unit, I make it to be this outdoor unit 2. The capacity is higher than outdoor unit 1, just follow our instructions. And also for the mood exchanger, although it is just 5 indoor units, but you can find that here is the branch. That means there is one branch mode exchanger and this 2 branch mode exchanger, and this is also one branch mode exchanger. It not only one indoor unit, but multi indoor unit it can connect, right? And inside this mode exchanger, which is inside this branch, there are this 1, 2, 3 solenoid valves and one of these EXV to control the refrigerant to the branch, which is we need to control whether we need to offer the hot gas from the high pressure gas pipe to the indoor unit or offer the low pressure gas, which is make the low pressure gas go back to the outdoor unit. And later I will show you the detail for your better understanding. And also you can find that this is the liquid pipe of the indoor unit. There's no solenoid valve or EXV to stop it, so the refrigerant can get through directly to the indoor unit and only get metering in cooling mode in this indoor unit EXV. Meanwhile, for your better understanding, I make all the indoor unit, the capacity is the same, which is to be 36 kBTU. And this is just for your better understanding. In the whole system, we divide the operating mode into this 5, which is the cooling mode. On the outdoor unit, it will display this AC, and cooling prevailing mode display QC, heating mode AH, heating prevailing mode QH, and also this completely heat recovery mode QA. So you can find that this QC, QH, QA is not that familiar, right? And that is not an error code, just display the operating status. And the heat recovery system will decide which operating mode just based on the indoor unit, either it is cooling or heating. And I will show you the detailed judgment. First, let's focus on this cooling mode. And the requirement is all indoor unit require cooling, which is there is cooling required indoor unit exists, but no heating required. In this example, I just assume this indoor unit 135, 134 require cooling. So we need to send the refrigerant, which is from the outdoor unit. This is already the liquid. Then send to the indoor unit. You can find it, there's no valve to stop it. So we just go to the indoor unit EXV and do the metering. And itself will become the low pressure and temperature. Then you can do the cooling in the indoor unit, then become gas and flow back to the mood exchanger. Just stop here. So just like what I had introduced, we need to control these 4 valves to conduct the gas refrigerant to flow back to the outdoor unit, which is we need to conduct to the low pressure gas pipe, which means we need to turn on these 2 solenoid valves. Just like this. Then it will flow back to the outdoor unit. Meanwhile, you can also find that here is the high pressure gas pipe. We always, which is from the outdoor unit, we always offer the hot gas also will to here. and just waiting the indoor unit. If it changes to the heating mode, then we will conduct this. But at this time, it is the cooling mode. So these two keep fully closed, right? And at the outdoor unit, they need to release heat, which is this. And this is the cooling mode. To the cooling prevailing mode QC. What we call it cooling prevailing, it is because the system is still in cooling mode. Just a few indoor unit require heating. And here is the judgment, which is the total indoor unit require heating, the capacity, plus the compressor input less than the summarize of the indoor unit required for cooling, the capacity. So in short, the system still need to release heat in the outdoor unit. And for the illustration, so you can just count how many indoor units for cooling and heating is fine, because I make it to be all the same, 36 kBTU. So, and in this case, I just make this indoor unit 2 and indoor unit 5 to be heating mode. So let's focus on this indoor unit 2, as this time it requires heating. We just provide the hot gas, which is from here, just like this, to turn on these two valves to supply the hot gas to the indoor unit 2. Then it will release heat, which is doing cooling. Then the gas will become liquid and go back to here, and which is the mode exchanger. Then it can join the liquid refrigerant to provide to the cooling indoor unit. As for this indoor unit 5, first of all, is this possible? Because this indoor unit 4 and indoor unit 5 just share the same branch. Okay, and this is impossible because just like what I said, is they just share the same branch. The operating mode of this indoor unit 4 and indoor unit 5, it will be the same. Actually, this will change to be the heating mode, but for the illustration, I just make it to be cooling for better understanding. So you just would need to understand, if they share the same branch, it will become the last call to change the operating mode. We go to the heating mode. The judgment is all the indoor unit required is heating, also means there's no cooling indoor unit required. And in this example, I just assume this indoor unit 1, 3, 4 require cooling, and then we always offer the hot gas from outdoor unit to the high pressure gas pipe. Then it will go to here. As this time, the indoor unit, this indoor unit 1 require heating, we need to offer this hot gas to here. And then we will turn on this EXV first, then we make the pressure between the solenoid valve left and right side, the pressure difference becomes smaller. Then when we turn on this solenoid valve, the noise will become much smaller, just like this. Then the refrigerant will get into here and release heat. Then the gas will become liquid and go back to the outdoor unit, just like this. And also you can find that the indoor unit EXV, this is not for metering. The purpose of this one is just to make the refrigerant to divide evenly, which is the balance between the heating on indoor units. Meanwhile, this low pressure gas pipe is still sucking the refrigerant back to the outdoor unit, just like this. This is always the low pressure, and then the refrigerant will get into it from the liquid pipe and make metering. Then it need to absorb it, which is doing cooling, just like this. The Wailing mode, the judgment is this one. That is the summarize of the indoor unit required for heating, the capacity, plus the compressor input power. The summarize of these two is higher than the summarize of the indoor unit required for cooling. In other words, the outdoor unit still need to absorb heat, which is in this one. And in this example, I just assume this indoor unit 2 and indoor unit 5 require cooling. So we just need to send the liquid refrigerant to the indoor unit 2, and then it can make metering at this indoor unit EXV, then become low pressure and temperature. Then this refrigerant can absorb heat, which is the indoor unit 2 will do cooling, and the refrigerant will become gas and flow to mood exchanger. Then it can join with the low pressure gas and flow back to the outdoor unit. As for the indoor unit 5, first of all, is this possible? Similar, right? It's impossible because indoor unit 5 and indoor unit 4 share the same branch. There is only one either cooling or heating operating mode, and it will become mode conflict. And due to the last call, which is this one is turned on later, then the whole branch, the operating mode will become cooling. But just for illustrate, I will make it to be the heating. Just like this. From here, you can also find that why we call the heat recovery, the efficiency is high, is because we can use the indoor unit to absorb heat or release heat, which is to help the outdoor unit to do this job. And in other words, we can have a bigger size of either the condenser or the evaporator. So for the efficiency, it will become very high. Thus, we go to the completely heat recovery mode, and the judgment is this one. In other words, the release heat and absorb heat, the capacity is almost the same. And for this completely heat recovery mode, the purpose is just to make the refrigerant just flow between the indoor unit for cooling and heating. And here is the refrigerant how it flow. First, we focus on to release heat, which is this indoor unit 1 and 3. So the refrigerant always from the outdoor compressor and then goes to here, as this indoor unit 1 and 3 require heating. So we need to send this hot gas to the indoor unit. Then it will absorb the cooling, which is to doing the heating. Then we become a gas to liquid, and then send the liquid also back to the mood exchanger. Why we need to send to here is we need to offer this liquid refrigerant for the cooling indoor unit, right? Which means we need to send this liquid refrigerant directly to the indoor unit and make metering in the indoor unit EXV. Then the refrigerant can absorb heat, which is doing cooling. The refrigerant will become gas and also fall back to here. The target or the destination is the outdoor unit, so we need to conduct this gas pipe of the indoor unit to the low pressure gas pipe, just like this. Then to the outdoor unit, and in TMV6, we still need to send a little bit refrigerant from the liquid pipe back to the outdoor unit. Do you know why? Just like this. A little bit is fine. The reason it is that the outdoor unit, we apply the refrigerant to cool down the compressor dry, and we need to send a little bit refrigerant just to cool down the compressor dry to avoid overheat. And here is all these 5 operating mode judgment just for your reference. That's all for this sharing. If you still have any other question or further concerns, feel free to contact me on this email address. Meanwhile, you can also scan this QR code to access the shared material. Hasta la próxima. それではまた今度。